Welcome to our 8.3, 8.4 notes video. In this lesson, we're going to take a look at Venn diagrams involving three sets. And we'll be solving some problems like this first example that says, shade the region on the Venn diagram indicated by the given expression. So what we're going to shade is we're going to shade the intersection of two sets. One set would be the union of A and B, and the other set would be C. So as we think about what we're going to shade, remember that an element is in the intersection of two sets if it's in both sets at the same time. So what I'm going to do is I know that every element that I shade has to be an element of C. So what I'm going to do is I'm just going to mark off. Now this is not actually part of the answer. I'm just marking off what is not included. So for example, all of this area inside the rectangle but outside of the three circles would not be shaded because none of that area would include an element that belongs to C. So all this X means is that I'm not going to shade there. I'll end up erasing that a little bit later. Also, this area, this region inside of A but outside of C, if it's outside of circle C, I know it cannot be in the intersection of these two sets. So I'm going to put an X here. Also, same thing here. This little area is outside of C to be in the intersection of these two sets. It has to be in C, so I'm not going to include that. Also, I won't include this area because, again, all of this region is outside of C. So I know none of that will be shaded, but what will be shaded? I need to shade everything that's both in C and the union of A and B at the same time. So as I look at this area is in the union of A and B, because to be in the union of two sets, an element just has to be in one set or the other or both. So this area is in the union of the two sets. It is also in C, so it's in the intersection of these two sets. So I'm just going to put a little check mark there. I know I want to shade that. The same thing here. We're inside C. We're also inside the union of A and B. So I'm going to put a check mark there. And likewise for this area, I'm inside C. I am also included in the union of A and B. So everything that I have a green check mark on, that's what's going to be shaded. So I'm going to erase all those markings because they really have nothing to, they're not the actual answer. But I can shade in my answer then. Let's see, I think I'll grab a highlighter. So the area that we're going to shade would be this area right here. And that would be all of the elements that belong to the intersection of set C and the union of A and B. All right, and then let's take a look at example B, which now we're going to shade in the union of A and all the elements that are in the intersection of B and C. Now remember, for an element to be in the union of two sets, it needs to be in either one set or the other, or it could be in both, okay? So again, I'm just going to look at each region. Let's talk about inside the universal set but outside the three circles. Well, any element that would be out here is neither in A nor in the intersection of B and C. So I'm just going to mark an X there. I won't be shading that region, okay? I will shade this region, okay, because here I'm in A. Remember, to be in the union, it has to be in one set or the other or both. So anything in A is in the union of those two sets. So that means I would shade here and here and here, okay, because that every element of A belongs to the union of these two sets. To be in the union of these two sets, it has to be in one set or the other or both. All right, so then let's look at this area. Now this area is neither in A, it's not in set A, and it's not in the intersection of B and C, so we would not shade that region, okay? This region here is in the intersection of B and C. These elements belong to B and C at the same time, so since it's in the intersection of B and C, it would be in the union of these two sets, so we'll definitely shade that region. And then that just leaves this region down here. Now, this is neither in A, we're not in set A, and we're not in the intersection of B and C, so we would not shade that region, okay? So now that I have an idea what to shade, I'm going to erase those marks and shade in my final answer. Okay, and the reason I'm erasing the marks is because I don't want you to think that the checks and the X's are part of the answer at all. I was just using them to help my thinking. So my final answer would be all of A. Let me shade that in. All of A, and then this little piece of the intersection of B and C. Okay, and the next thing I want you to think about is, what does this expression mean? We have an A, a union symbol, B, an intersection symbol, and C. And the answer to that is, this really means nothing, because without some grouping symbols, we can't make any sense out of that. So this means nothing without parentheses. Okay, so whenever you see an expression that involves three sets and intersection unions, there's going to have to be a set of parentheses to give it some meaning. All right, then let's take a look at this next example. It says that, let me move this up just a little bit. It says that a teacher asks her class how many of them study chemistry and finds that there are 15 that study chemistry. She then asks how many study biology and finds that there are 13 that take biology. In addition, she discovers that 5 of her students take no science at all. So later she remembers that she has 26 students in her class, but if she adds the 15 chemistry students and the 13 biology students and the 5 students that take nothing, that totals 33. So she wonders if she has miscounted. And of course she hasn't, but what we can do to help resolve this situation is to use a Venn diagram to help us with our thinking. So the rectangle, the universal set, would represent all of the students in the teacher's class, okay? Set B would be the set of students that take biology, and C would be the set of students that take chemistry. So the reason why she ended up with 33 instead of 26 students is because obviously there are students that take both chemistry and biology, and they got counted twice. Now we don't know how many of those students there are, so let's just let X represent the number of students that take both biology and chemistry. So then what we can do is we can write an expression for these students here. These are the students that take biology only. Okay, so we have 13 total that take biology, X that take both sciences, so the expression for the number of students that take biology only would be 13 minus X, and likewise, since there are 15 students that take chemistry, 5 and X students take both sciences, then 15 minus X would be the number of students that take chemistry only. And then let's not forget that there were 5 students that take no science at all, so they should be inside the universal set but outside of the biology and the chemistry circle, so I'm just going to put those 5 right there. Okay, so now to figure out how many students take both chemistry and biology, let's just write an equation. If we take these 4 expressions, we have the students that take biology only, the students that take both, the students that take chemistry only, and then the 5 that take no science. If we add those 4 expressions together, they should total 26. So let's go ahead and write that equation and solve it. So we would have 13 minus X, the biology only, plus the X students that take both, plus 15 minus X, the chemistry students, plus the 5 that take no science at all. That's going to total 26, all right? So solving that equation, let's gather like terms. We would get 33 minus X is equal to 26. Then I'm going to subtract 33 from both sides, and we get the opposite of X is negative 7, so therefore X equals 7. All right, so now we know how many students take both, so we can figure out what students are taking what science. So if 7 students take both biology and chemistry, then the number of biology only students would be 13 minus 7, or 6. So we have 6 students that take biology only. Okay, we have 7 students. Remember, X was 7, so we have 7 students that take both. So 7 students take both sciences. And then we'd have 15 minus 7, or 8 students that take chemistry. And then don't forget about the 5 that take no science. Okay, if you total 6, 7, 8, and 15, that totals the 26 students that are in the class, and the mystery is solved. All right, let's take a look at another example. This one says, in a class of 29 students, we have 19 that study German, 14 that study Hindi, and 5 that study both languages. Work out the number of students that study neither language. Okay, so of the 29, there have to be some that take no language at all. So let's go ahead and fill out what we know. First of all, the number of students in our universe, in our universal set, that would be the number of students in the class. There's 29 of those. So the number in the universal set is 29, okay? And then let's let G be the set of students who take German. The number of students that take German is 19. Whoops. 19. And then I've got a typo here. Sorry about this. This should not be a U. That should be an H. So if you could change that to an H, then this would represent the number of students that take Hindi, and that is 14. And then we're told that there are 5 students that take both. So the number of students in the intersection of the students that take German and the students that take Hindi is 5. Okay, so what we're being asked to find, let's go ahead and label our diagram. We know we have 5 students that take, 5 students that take both languages. Okay, so that means if I have a total of, 19 students that take German, 19 minus 5 is 14. So I have 14 that take German only. And then I'm going to take 14 minus 5 to get the number that take Hindi only, and that would be 9. Okay, so what is that total? That totals, 14 plus 5 plus 9 is 28, and since there were 29 students in the class, that means that there's just one student that takes no language at all. One student that takes no language at all. So the number of the intersection of the students that don't take German and the students that don't take Hindi, that number would be 1. Okay, then let's take a look at one more example. In this last example, we're told that 145 people answered a survey to find out which flavor of fruit juice, orange, apple, or grape, that they preferred. And we got the following replies: 15 like none, 55 like grape. Well, you can read all of these outcomes. Okay, so the question is, find the number of people who liked all 3 types of juice. Okay, so that's our unknown. Why don't we call that unknown X, and we're going to go ahead and label it on our Venn diagram, and it would go right here because this would be the intersection of all 3 sets. So that's where we're going to put our X for the number of people who liked all 3 types of juice. Okay, now there's one other thing that we can label right off the bat, and that is this: the 15 people that liked none of the 3. So they would be in our universe of the 145 people surveyed, but they'd be outside of all 3 circles. So I'm going to put those 15 people right here. Okay, so now let's start labeling here. And I'm going to start with these intersections, okay? The 35 people that liked orange juice and apple juice. So here's our people that like orange juice. Here's our people that like apple juice, okay? So the ones that like both might also like a third. So, like the grape juice. So to write an expression for this region, we're going to have to take the total that liked orange and apple and subtract these people that like all 3. So we're going to write an expression 35 minus X right here, okay? So maybe we should check these off as we take care of them. Okay, now we've already taken care of that. Taken care of the 15 that don't like any. Okay, so now let's take a look at this. 20 liked orange and grape. Okay, so the intersection of orange and grape would be right here. So we're going to take the 20 that like both of those and subtract X, the number of people that liked all 3. So we're going to put a 20 minus X right here. All right, and then let's think about the 30 people that liked apple and grape. So here's our intersection of apple and grape. So let's take 30 and subtract the X that like all 3. So 30 minus X. Okay. So now we just have 3 regions that we need to label, okay? The people that like orange juice only, apple juice only, and grape juice only. So let's start with orange juice, all right? So we know that a total of 75 people liked orange juice. So what we're going to have to do is we're going to have to take 75. Let me write it. I'll write it right here. We're going to take 75 people. Let's see. 75 people that liked orange juice, and then what we're going to do is we're going to subtract the sum of all three of these expressions. So it's going to be 75 minus 35 minus x plus 20 minus x. All right, so again, I took the 75 people that like orange juice, and I'm subtracting the sum of all three of these expressions. All right, so now when we go to simplify this, we need to be careful. Why don't we start by simplifying the constants. If I take 75 minus 35, and then we're also, well, 75 minus the sum of 35 and 20, we're going to get 20. So the constant would be 20, okay? And then we might want to make this simpler. Let's just, inside the parentheses, let's simplify the x's. Negative x plus x cancels. So let's just get rid of a couple of those x's. And then what we need to remember is that we're subtracting this negative x. When you subtract a negative, that's the same thing as adding a positive. So 20 plus x then is the expression of people that like orange juice only. So I'm going to put that right here, 20 plus x. All right? And then let's do the same thing with apple juice. We have, let's see, where's apple juice? We had 80 people total that like apple juice. So if I take 80 and I subtract the sum of all three of these, let me just write it down so we can keep track of that. So if I take 80 and I'm going to subtract the sum of 35 minus x and 30 minus x, okay, and simplify that expression, then we're going to get, let's see, 80 minus 65 is 15, okay, and then when we combine our like term, we can combine a couple of x terms and cancel those. And remember that we're subtracting this negative x, so that's going to be 15 plus x would be the expression of people that like apple juice only. Okay, and then last but not least, let's talk about grape juice people. So the 55 people liked grape juice. So if we take 55 and we subtract the sum of, we're going to subtract 20 minus x and 30 minus x, the sum of those three expressions. So that would be 20 minus x plus 30 minus x, okay? We'll simplify that expression, and it turns out to be 5 plus x, all right? So 5 plus x is the expression for the number of people that like grape only. Okay, so now we're ready to write an equation and answer the question, which is the number of people who like all three. We can solve an equation for x. So what we're going to do is we're going to add up all, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 expressions. We're going to add all 8 of those expressions together and set it equal to 145. All right, so that would look like this. We're going to take 20 plus x plus 35 minus x plus 15 plus x plus x. Oops, that should be a plus sign. Sorry about that. All I'm doing is I'm just adding everything up in that Venn diagram. So plus x, and you can do these in any order, of course, plus 20 minus x plus 30 minus x plus 5 plus x. So I'm running out of room here, okay? So I've added everything except for the 15 people that like no juice, and then that's going to total, this is a mess, I'm sorry, that's going to total 145. Okay, so let me just reiterate what's happening here. All of this is the sum of all 8 of these expressions, okay? Add them all together and set them equal to 145. Now, when you gather all these like terms, you're going to, it simplifies quite a bit. You're going to end up with x plus 140 is equal to 145. Subtract 140 from both sides, so we get x equals 5. So that answers the question. Remember, it said find the number of people who liked all 3 types of juice. We let x represent the number of people that like all 3 types of juice, and so that answer is 5 people. All right, so you'll be doing some problems like this in class, so if you have any questions, be sure and ask me then.